All right, let's get started. Hello everyone, my name is Aijaz Ansari, and I am a teacher and a mentor and a software developer. I write software for the NBA, and NCAA basketball coaches for basketball sports. And I want to thank them for giving me the opportunity to be here with you today and speak to you about something that I'm really, really excited about. I've been writing software in some form or another for a really, really long time. One of the things that I've learned over the years is that one of the most useful skills that we can have as software developers is the ability to debug our code quickly and efficiently. We've got LLDB, we've got with XCode, and since XCode 4.3 we've had LLDB. I'm really happy with LLDB. It's an amazing debugger. It works really well. It integrates really smoothly with all of the other tools that Apple has made available to us, and I couldn't be happier, except for a couple of minor things, which we'll look into. There are a couple of minor annoyances that, to stretch the metaphor a little bit, they add sticking points. They're like sources of friction that interrupt my workflow, and they make things slower than they ought to be. And taken by themselves, they're not such a huge deal, but when you're faced with this every day in and day out, several times a day, it starts to get a little annoying, but there are ways around them. So I cracked up with the documentation, read about it a little bit, and I was able to solve the problems that I was having. And that's what I want to share with you today. I want to show you a couple of things that really improved my cycle time from finding a bug to seeing what the bug is, analyzing, fixing. That entire cycle time was reduced significantly enough that I couldn't be more excited about what I'm going to talk to you about today. And I really hope it helps you as much as it has helped me. Especially if you're writing any applications that deal with, in this case, that deal with REST APIs or getting data from a remote server. Because then you will be faced with exactly the same issues that I would face, but you'll be able to have the same tools that I did. So let's, in order to show this to you, I want to illustrate this with an application. So I have a demo app. It is a conference app. And what we'll do is we'll look at this app. It's a very straightforward app. It's a UI split view controller. You can have a look at the UI table view for the master view, a list of sessions. You can tap on a session, get a session detail, tap on speaker bio, get a speaker bio. It's a very straightforward UI split view controller. But it's got some bugs in there on purpose, and we're going to look at that. It's got three view controllers: a master view controller that's a UI table view, a detail view controller that's a session detail, and hanging off of that is a speaker view controller. As far as model classes go, we've got two classes: a session class for containing data about a session. There's a session time, date, title, things like that. Got a class for the speaker. The speaker's information, their name, their bio, their website, their picture, things like that. In this app, the assumption is that every session only has one speaker, so there's a single reference, a strong reference from a session to the speaker. And because the speaker could have multiple sessions, there's a collection of weak references back from the speaker to the session, so that we don't have retained cycles. Now, in the code that's out there on GitHub, there's actually a bug in this. And if you're interested, you can solve that bug. We're not going to look at that bug today. There's a memory leak. We're not going to look at that today. We are going to look at another bug that, let me just go ahead and show it to you right now instead of talking about it. Let me reset, make sure everything's okay. Any second now? So that's one. And time keeps ticking away. All right. So here's our UI table view controller. Everything looks really good except for one entry. Should be somewhere over here. Where is it? Right there. You see this one entry doesn't have a title. Chad Perks entry doesn't have a title. When you look at the detail, it doesn't have a title in there as well. And everything else has a title. So as an iOS developer, when I see something like this, my first instinct is to say, hey, not my fault, right? It works in every case except for one. So most likely, since this is an app that gets data from a REST web service, Maybe I'm not getting all the data that I want. But I can't say that unless I have proof, so I need to investigate this. The other thing is that, if what I need to do is I need to break into my code and look at the session object. If it's got a title and I'm not displaying it, then the problem is definitely on my end because I have a title and it's showing up as blank over here. If there's no title, then I can say, okay, it's probably the JSON that's coming back. So that's what I want to do. So what I'm going to do is I'm going to go into my master view controller where I segue to my detail view controller, and I'm going to put a breakpoint right here in breakpoint right after I get my session object in prepare for segue. I get my session object based on my index path, the index path, section, and row. So I get a session object. I don't need to restart the app. I'm just going to go ahead and tap here. Here's my breakpoint. And immediately I see a couple of things that bother me. Remember I was talking about those little annoyances? So here are the first two annoyances. Let me, you may not be able to see this too well, but okay, here you go. So we've got, on the left-hand side of this debug window, we've got a list of variables that are available in my scope right now, or in my frame, or in the block of code in which we've stopped right now. So that's really useful. I've got the segue, the session, the index path. What I don't like is that this doesn't tell me anything. Neither does this. Very often I need to look at the index paths. And yes, I can tap here, and I can go here, look at the indexes array, section 1, row 0. I can go here and do all of this, but I'm too lazy and I don't want to do that. I just want to get through this as soon as possible. So this is the first minor annoyance that I want to fix right away. What I really want is to tell LLDB that, hey, when you're showing these things, they're called summaries. They're variable summaries for variables of this type. This type is myconf.session, because the program is called myconf and the class is session. It's LLDB is just giving me the pointer. I don't care about the pointer. I want the actual information. I want the session title. I want the session name. So I want to tell LLDB, give me these two pieces of information. Turns out LLDB has a way of doing that, and let's do that right now. I'm going to go back over here. I'm going to type in type summary add. So these are all LLDB commands. The type summary, I want to add a summary string for this object, my conf.session that we just spoke about. And I want to do simple string substitution. The object that's going to be described is going to be stored in this thing called var. I just want to say, show me var.title and var.speaker.name. Really useful. This is extremely useful. I'm going to do that, hit enter. I'm going to do the same thing for you for the index path because I use index paths all the time, So do the same thing right here. Type summary add. Notice nothing's changed on the left-hand side because we already printed it out. So we need to stop there one more time. So I'm going to continue, get back here, and tap here one more time. For the demo purposes, I'm just going to tap on the first one because I don't want to scroll too far down. Okay, so here's my breakpoint. This is the first level of awesomeness, right? 1 and 0 is great. I love this. The fact that I can do that, thank you, LLDB developers, for giving me this. This is really cool. Thank you for giving me this. I can see the title, by, and the speaker name. I don't like the fact that there is a quote over here, so I want to get rid of that. But there are other things I don't like about it. The first thing I don't like about both of these things is that I don't want to have to type this in every time I run XCode. Because that's stupid. I want, as you can imagine, there's a way to get around that. I want to put it in an init file so that every time I run XCode, it's already there for me. So that's fine. But I don't want that to happen for the session object because I don't always work on this project. I may work on another project that doesn't have a myconf.session. Why should I have my computer spending CPU cycles trying to figure out how to display a session object when there is no session class in that application? So I don't want this to happen every time. I want this to happen only when this application is loaded. So let's look at the first problem first. Let's do something with this index path. So what I'm going to do is copy and paste what I typed in here into a file called, LLDB init in my home directory. Just a bunch of LLDB commands. It's like we typed them in the command line. I'm going to save this, and just to keep myself honest,
I'm going to quit LLDB, quit XCode, launch XCode again. I might set a record for most amount of time to see a quick XCode during the session. Yeah, this is brave. This is courage. So here we go. Come on. Great. So you see, we've solved this problem. I didn't type in anything, but it shows up over here. So that's what I want. Now I need to deal with this session thing. I want the session thing to show up over here. So I said I want to have this session summary string be computed only when I open this app and not when I open other apps. That's one of the problems with the session summary string. The second problem, and a bigger problem, is that the syntax that LLDB gives me for displaying a summary string, it's too primitive. It's very limited. It's just like a simple string substitution. I can't really do too much with it. What I really want to do is I want to compute the values of the session. I want to be able to say, well, look deep inside the session. Look at this field, look at that field, and then concatenate some strings, maybe do some computation, format a date or whatever, something really complicated, and then construct a summary string out of that. What I really want to do is write a function in some programming language. I need a programming language to write a function that gives me a summary string. Turns out, LLDB gives me a full-fledged programming language that I can do with it. And the language that they give me is Python. And I can, from the LLDB command line, I can get a Python REPL by typing in the script. And now I have the full power of the Python interpreter right here. I can write Python code in here. I can import modules, everything that you can do in Python, I can do here. It's cool, but so what? What Python gives me is the ability to speak to LLDB. What that gives me is that LLDB is debugging a program in some language, Swift, Objective-C, C++. LLDB exposes that code to me, to my Python scripts. And Python, in turn, can do stuff and send it back over to LLDB. So that's really cool. And let's just go ahead and get started with this. So I've stopped right here in my prepare for segue. I'm in a block of code, and I know we have several different ways of seeing this, but there is in my frame right now, I have this variable called session. Let's see if Python can see it. What I'm going to do is I'm going to get access to my block of code right now, which is called a frame. Let's have a look at a frame. Okay, we've got a frame. In my frame, I have a variable called session. The name of the variable is the string session. All lowercase, it's a string. There's a name of the variable. I'm going to assign that to something called session var. Great, so now I have the variable. Let me hit enter. I should be able to see my session right now. I type in session var, and I don't. What I do see is this thing called LLDB.SBValue. What is an SBValue? An SBValue is a class that wraps up a variable in the language that the program that's being debugged is written in. So I've got access to my session variable, and it's wrapped up in this thing called an SBValue. An SBValue is a really useful thing, because once I have an SBValue, if my intuition is correct, I can read the docs and figure out how to get data out of that SBValue. I know a session variable has a title, so maybe I can go and look for the title of this session, and let's go ahead and do that here. I'm going to say title var is the session var dot get child member with name title. Okay, that seemed to work. No errors. What is title var? No surprises already is also an SBValue. I know that this is a string, and I can call description on a string. So if I'm right, I can say title text equals title var and get object description. Give me the description of this thing. Now if I type in title text, what do I see here? Okay, that's my string. That's my title right there. This is Swift. It's an optional string, so I get like the debug description of the string right here. I don't want all this crap, and I can quickly remove all of this by doing some simple regular expressions. I'm just going to go ahead and do this right now in the Python REPL, just to show you how straightforward it is. Let's see, I'm going to import the regular expression module. I'm going to create a regular expression that says just find anything within quotes. Sorry, find everything within quotes and just return me that. And then I'm just going to say if we have a match, then give me the first thing that matches. If I print match, I get just the string I want. That's great. I mean, this is just for my own personal preference. There's nothing wrong with seeing all of this. But when I have this display over here, I want to see the word optional and the word string and then the backslash n, because I just want it to be as pretty as possible. So I'll use regular expression. So maybe what I'd like to do is write a Python function that does this, get me the session title, get me the speaker name, strip all the cruft from the strings, and then construct a summary for me. So, and I only want this to happen when this app is run. So I'm going to do this first, and then when we get back to the slides, I'm going to show you how it was done. What I'm going to do first is I am going to ask myself, where does the program, what place am I guaranteed to hit once and only once during the start of my app? This is a Swift file, so a Swift application. So I'm going to go to application definition launcher. I want to somehow do whatever I want to do in application definition launcher. So I'm going to go to my app delegate. And then in application definition launching, I'm going to set a breakpoint right here, right before I return. If this were an Objective-C app, I would probably put this breakpoint in main. I'm going to right click on here, edit breakpoint, and then in this little window that pops up, I'm going to say, add an action, a debugger command, and I've created this file. I'm going to say source, this file that I haven't really described to you yet, that's named .LLDB init-markdown. What does source do? We'll see that in a second. And then I'm going to click this little thing that's really important. Automatically continue after evaluating actions. So what this does is, in application definition launching, the breakpoint's going to get hit. The program is going to stop. LLDB is going to take over. It's going to execute this command as if I typed it in from the command line, and then it's going to go back and continue the program as if nothing happened. But this thing is now imported into LLDB. Now LLDB knows whatever was there in this file. So I'm going to go ahead and do that. And I'm going to quit XCode. Restart XCode. To show you it works, and then I'll show you why it works. Run. There. Took a second the first time while it was evaluating the code, but I still have this, but now I have this. And this time, this is through Python. Python generated this text. I don't have the quotes, I have this text exactly the way I want to. I could do arbitrarily complex things in here. You probably don't want to do this if you're going through a heavy debugging session because, it takes CPU cycles, but it's possible. I think that's really cool. Let's see how we did it. Okay, we're going to take a little break while we think about everything that we learned, and our speaker has a glass of water. Talk amongst yourselves. All right, that's enough. Let's recap. What did we learn? We can have quick and dirty type summaries. We can tell XCode, hey, I work with index paths a lot. I don't want to see, I don't want to just see two indices. I want to create a summary string for index path. It's really nice. It works really well. So I'm going to do that. I'm going to put that directly in my LLDB init file so that from now on until I change my computer, it's always going to be there. And I will never see that old thing again, and then it'll be there for good. I could also do the same thing for my session. But I don't want to do this for the session because I don't want this to run every time. So we figured out, okay, we're going to do something in Python. What exactly did I do? What was that? Summaries in Python. The first thing I did is I created a Python file. And this is on my drive right now. It's a file called sessionformatter.py. I can call it whatever I want. I chose to call it sessionformatter.py.
In Python, the file name can also be thought of as a package name. So you could say that this package is the session formatter package. And the first thing we do when we Python thing programs is import whatever modules we need. I don't like that stuff, so I chose to create a utility program that gets rid of all the extra junk and just prints out the text. So I created a regular expression. Now, this is exactly what I typed into the command line, right? I mean, from the from the Python REPL in LLDB, I just saved it to a file. I created a regular expression. I created a little script quotes utility function that just takes, it finds the quotes, it returns everything inside those quotes, and gets rid of everything outside the quotes. If the regular expression doesn't match, well, we try, just return whatever we had in the first place. Okay? This is just a utility function, it's not really required. Then, once that was done, I created a function called format. I can call this whatever I want. I chose to call this format. My intention is to tell LLDB, hey, LLDB, I want to register this function as the function to be used when you try to print a type summary for some variable to be named later. And LLDB, in turn, will say, okay, I will call this method, and I will call this method with two parameters. The first parameter is the one that I care about, valObj. You can call it whatever you want. valObj is the SB value that we looked at. Right? Remember the SB value? That's what I get. Because I'm inspecting a variable. A variable is passed to my Python interpreter as an SB value. So now everything that I typed in on the Python REPL, I have through here, through this valObj. So just like I did in the REPL, I can say title equals get child member with name title. So give me the title of this session object. Give me the name of the speaker by doing valObj.speaker.name using the proper methods to access the child, the children. And then I just do a little bit of my cleanup. I call script quotes on get object description. I add the word by, and I call script quotes on get object description on the name. So I get keynote by Dishan. Okay. So that's nice, but it gets better. LLDB promises me that, hey, if you import a package, a Python package into LLDB, LLDB will look for a method named __LLDB _init _module. And if the method exists in that package, it will invoke that method, calling it with two parameters. The first one of which I really care about is the debugger. So I have pointed to the debugger, to LLDB. What can I do with LLDB? I can type in commands. So I can tell LLDB what I would have typed in. And I can just say, okay, I'm going to construct a command, type summary add my Python function. So I want you to use this function, format, which was over here, in this package, which is over here, for this class in this module. And that's what we have. Session formatter is the package name. Format is the method that I'm registering. Once I create this command, I just send it over, I just send it over to LLDB with handle command. And it's like I typed it into the command line. Just the act of importing the file also registers the format method for my session object. That is really cool. Then, the last thing I did is, now there are two ways I could include that package. The way I prefer is the following. I created a new LLDB init file. I call it LLDB init-myconf. I can call it whatever I want. I choose to call it LLDB init-myconf. And in there, I added the actual import. Command script import, whatever the full file name that I wanted to fit on the slide, so this is the full file name file package. Command script import session format.py. That's this file right here. That's what I'm importing. And again, like I said, importing this registers that function. So if somehow I import this file, that imports this file, that registers this method for that object. So the problem has now been reduced to, how do I import this file? I'm sorry, this file. And we already did that by setting a breakpoint and saying, okay, in breakpoint, command source this LLDB file. Why did I choose to use a separate file? Because later on, I can add more stuff when the app grows and I have more classes. I'm just going to add it in one moment. I'm just going to add one for every type. And then this, and the other reason, the big reason why I like doing it this way and not over here, is because now this is all in source control.
and every developer has access to it. And if this changes for some reason, that's also in source control. Any questions about what we did so far?
Was that in like a triple dot or the paths?
No, the triple dot was just because I didn't want to type in the whole thing. It would fit on the slide. The question was, the triple dot, was that the actual thing? No, that was just a short button. You had a question.
Is it possible, so if you have that in source control, someone else takes it down, they're not going to have that breakpoint set, right?
Correct. The way I have it set up is that they don't have,
So they have to type it in again.
they would have to set the breakpoint in again, unless, here's a really cool thing, unless I set the breakpoint in this file, I could do that. It's an LLDB command. I could type in B space, file name, line number, if I wanted to.
Is there a way to like put in the schema or somehow this, like, something else load this file, the mycon file?
Sure. So the question is,
breakpoint?
yeah, so the question is there some way to do something in the schemas so that the breakpoints will be loaded in?
Yeah.
I'm 99% sure the answer is yes, and I'm 100% sure that's not the way I prefer to do it. And it's just personal preference. My personal preference would be, I'm not saying it's a bad thing to do. My personal preference would be to put it in here. Because this is something that I'm familiar with, and I can see it easily. And I may not be that familiar with, putting it in some other way. But yes, it's possible. Any other questions? Oh, sorry, yes, you.
How does it handle nil values? How do they come out?
I haven't tested it. The question is, how does it handle nil values? How do they come out? Wasn't planning on doing this, but let's just do it. So the answer to your question is, well, let me continue here. Oh, shoot, not there. Let me continue here. And let's look at the actual thing that had an error. I haven't really tested this, so nil by Chad Quirk. Okay, you just have to. I don't know what Python will give me. It gives me nil. The string nil. Any other questions? Okay. Let's go back to our slides. Okay, so when I think of JSON, I think of stuff like this. It's really easy to read. That's the whole strength of JSON. It's easy to read. It's easy to parse. But really, what happens is when a server sends me JSON, a server doesn't care about that. It wants to reduce the amount of data sent to the network. What I get is this. Right? And this is a small version, and there's no way I'm going to read through that correctly. So there is this tool called JQ that it's an application that's written in C. It's extremely powerful, and it's one of the best things that I found out when I started working on REST clients in iOS. It's ridiculously powerful. You can do things like obviously print JSON. You can transform your JSON. You can query your JSON. You can do stuff like grep. You can take matrices and you can transpose matrices. It's nuts. You can do you can do math and reduce. You can do functional programming with JQ. It's crazy and it's ridiculously fast. And what I used to do is when I wanted to investigate some JSON, I would stop in my network code where I get my callback and where I get my data, right? I'll convert that data to a string and print the string, feed over the string in LLDB, and then copy and paste everything, and then put it inside an editor or put it inside JSON, and then search for stuff. So that entire process takes about a minute or two, because invariably, in real life, my JSON would be so many pages long that I would wind up selecting 2 chunks of JSON with some LLDB commands in between, and then none of my JSON would parse. So that was really, really annoying, and that was the pain, the second part of the pain that I was talking about that I wanted to resolve. What I really wanted was the ability to have JQ be part of XCode. And I did exactly that, and this is what we're going to look at right now. But before we do that, I want to show you an example of how powerful JQ is. So I created an example JSON file that deals with characters from my favorite TV show, Avatar: The Last Airbender. So this is a JSON file, stored in a thing called avatar.json. I've got maybe 10 or 15 characters in here, and I just randomly chose some characteristics, and have it saved in a file called avatar.json. So I can run the command like this. I can say JQ, because now JQ has been downloaded from the internet. I've built it, I've done a compile on JQ, and it's there in my own home bin directory somewhere, right? So I call JQ from the command line on this file called avatar.json, and there's something in between, in quotes, We call that the filter. It's called the filter, but it's really like a JSON. It's like a JQ program. It's a filter because it takes input, does something to the input, and then prints out output. That's all it is. It's a filter. Input, application, output. It's one of the simplest filters out there. All it does is it pre-prints the JSON. So just this is super useful. If I type this in on my command line right now, and you'll have this in the Git repository as well, so you can try this out. Or you may not have to make sure I put that in there, but it's not part of the active. So if you type in JSON, what you see is screen after screen after screen of JSON nicely formatted, and it just scrolls past this, and you'll see right at the end, even this stuff is super useful. This last line tells me, the square bracket tells me that the top level JSON object is an array. It's an array of something. That's really useful to know. That second last line tells me it's an array of JSON objects or dictionaries, right? So that's really useful to know. I say, okay, what I'm getting, if I know nothing about the JSON that I retrieve, I already know it's an array of objects. What can I do with an array of objects? I can iterate on them. I can look at them. I can play around with it, right? If I say JQ for each item, this thing over here, dot and the square brackets, that's an iterator. That's a filter that returns an iterator. It returns a sequence of JSON objects. So I can say iterate over that array, because I know we have an array, because that's what I saw in the previous slide. For every item in that array, I want to run another filter and pipe the output of one filter to another filter. Essentially what I'm saying is for each item in the array, print out the keys for that item. And if I type this in on my command line, if I want the output of one to be the input of another, this is what I get. The first JSON object has the following keys: wedding, born, children, died, identity, name, sex, spouse. They don't all have to have, it's not a strongly typed, JSON isn't strongly typed or anything like that, so they could be different, right? But I can see all of them right now. In real life, they're almost always the same. I could get even more complicated. I could say for every item in the array, give me that character's name. So they can see all the names of all the characters. What if I wanted to grep? Grep for all the characters that are female. For each item in the array where the dot name field, the dot sex field is F, pipe it to the dot name. So I've got three filters and two pipes. I'm saying for each item in the array where the sex is F, extract the name. This is a list of all the female characters in that JSON file. That's really cool. Let's go look and see this at work right now. That's not what I'm doing. So again, like I did before, I'm going to do it first and then I'm going to show you what I did. All I need to do here, I'm going to get rid of this thing. We've already fixed that bug, or we kind of fixed that bug. I'm going to get rid of that breakpoint. I am going to go into my LLDB init file. I'm going to add one more type summary. I'm sorry, not type summary. I'm going to import one more Python file. I'm going to import a file named jq.py. I'm just going to do that, save the file, and then I need to quit XCode. So let's quit XCode. Let's restart XCode. Okay, before I start, 10 minutes. Before I start, what I'm going to do is, I need to be able to look at the JSON. Where do I get the JSON file? JSON from? I get it from my network code. So I'm going to go into my network code. I have a file here called network.swift. And in my network.swift, I have my call to my URL session data task. When the data task is executed, it completes, I get this data object. Now I want to get this data and view it as a string so I can print it out. So what I can do is and for stuff like this that's debug related, I prefer to do this as an if debug. So in if debug, I'm going to say create a JSON string from that data, and just so I don't get compiler warnings, I'm going to nslog that string. The only reason I'm doing that is because I don't want to get that stupid compiler warning. Because I know what I'm doing over here, right? I don't want to I want to be very sensitive to warnings. So okay, so I've got a JSON string over here. Let's set a breakpoint right here after I created the string. And let's run the app. That would help. All right. So before it actually even displays the thing, the display table view, it makes the JSON call, the network call. I got my JSON. Normally what I would do is something like this. Not that. And then copy and paste that. But now I don't need to do that because I import that jq.py file. I can now do, and this is the favorite part. This is what I've been dying to show you because this changed my life without exaggeration. JQ dot, if I can type, so excited I can't do that. JQ dot JSON string. Look at that. That's a third-party app that has nothing to do with XCode that I downloaded and compiled, months ago before I even knew anything, not months ago, years ago before I knew anything about this stuff. Now all of a sudden I have somehow made that third-party application an LLDB command. That is really cool. I've now extended LLDB. We could go and do a little bit more. Let's go and figure out what the source of the bug is. I could do this over here. Let me look at over here, same trick. Let's look at the last line. The last line is the curly brace. So unlike my slides, the top level object in here is a dictionary. Okay, if it's a dictionary, let's go look at the keys of this dictionary. It's got three things: sessions, speakers, and version. Okay, let us look at the speaker. Show me, or cycle through every speaker, iterate through every speaker, look for that one named Chad Berg, and give me that speaker's ID. That's what this line does. Give me the ID for Chad Berg. It's 14. This is really cool. Normally this would take me a minute to do. Multiply that by a huge API several times a day, and you can see how this is so useful. Okay, I got Chad's ID. Now let's go look at all the sessions that Chad is talking about, that Chad is speaking at. So that will be JQ3. Iterate through all the sessions, grab through them for those sessions where the speaker ID is 14, and give me the keys of the session. And here we have our bug. Here is session title, here is title. One of these is correct, one of these is incorrect. I don't know which one, I don't care right now, but we've found the problem. The problem is in the JSON. That is really cool. So, we don't need to fix this bug right now. Let's go and see how we got this to work. 7 minutes. We can do this. No pressure, no pressure. I'm just going to coast now. Okay. Deep breath. Think about what you just saw. Sorry, that was kind of gross. Swallows. All right. So here's the JQ command, right? JQ, speakers, keys, JSON string. If you think about it, what are we really doing? It's the stuff we learn when we learn programming day one. What is it? What is a program? It's something that does something based on some input, right? We've got a function that takes in some input and then does something with it and brings out some output. We're gathering our input. In this case, we're running a JQ filter on the input, and we're printing out the output. Anytime you want to create your own LLDB extension, create a new command in LLDB, it's not more complicated than this. This is exactly what it is. Get the input somehow, the thing that you care about, run something, do something with it, and print it out. Print out the output. How do you do that? Every Python file has like a list of imports. So this one imports commands, so we can run a command. It calls LLDB and it tokenizes it. So when I tell LLDB, hey, I want to register a function as a new command, LLDB will call it with 3 things. So we'll look at the debugger, a command, and a result. Just go through this real quickly. From the debugger, I can get the target. From the target, I can get the process. From the process, I can get the thread. From the thread, I can get the thread. And I put that all in one line because I wanted to fit on one slide. The command is this, right? So I'm going to split the command into tokens so I can get the filter and I can get the name of the variable. So I'm going to get the filter command 1. I'm going to get the SB value by calling frame.var. I should have done this in 2 steps, but I put it in 1 step. Then I'll get the string, the actual JSON, the actual filter string. Then I have some temporary variables to create, so I don't get very complicated code. Where is my JQ executable? I'm going to store the JQ filter in a file. I'm going to store the JSON string into a file. The reason I do that is if the JSON is very large, what's going to happen is LLDB is going to crash. And what's the point, right? The whole point is to continue working quickly. And what I found is if you save it to a file, you don't have to worry about the memory on that LLDB has. Okay. Then I write the JSON to a file, I write the filter to a file. Now I'm ready to actually go ahead and run JQ. All that's left is call JQ, do a man to JQ, figure out what the command line options are, get the output, print the output to this variable called result. Because that's what that will do is that will print it to the command line. That's what we just saw. It'll print it back to not the command, print it back to the LLDB console as we had had it. And the last step is just like before. Oh, sorry. Gather input, run command, print output. 3 steps. It's really all the same 3 steps every time, no matter what you're doing. The last step is, since we're importing this Python file, we can just say, take this Python function in this Python file and make it a new LLDB command called this thing, and then send them there. And that's basically it. What have we learned? I had a hypothesis. It wasn't my problem. That was my hypothesis. Why would they do hypothesis if they're lucky enough to have a hypothesis? If not, observe, look at the data, analyze, poke around with it. What's something wrong? Extend your tools. The LLDB is super powerful. You can extend it. And if you find yourself doing the same thing over and over again, you might be able to extend LLDB and make your own process even simpler. Any questions? Yes.
So it was really awesome to see you go back and find that.
Sure.
In the dictionary. I was wondering if there's a way for you to actually create a filter that said, like, give me all the non-matching structures to this.
So the question is it possible to create a filter that says giving all the non-matching structures? That's a JQ question, and in general, the answer is yes, JQ can do that. It's got a terse syntax. So I would say I'm 80% sure you can do that, but I'm not 100% sure. Yes?
So I arrived a bit late. How do you take your Python script and get the debugger to load it?
I will do my Python script to get my debugger to load it. Sure. So what I did is I put a line in my LLDB init file that said, because I want this to run every time, because I use JSON in almost every app. Almost every app I make is a REST client, and I'll have the slides, and they're already online in the Git. The repository is also already on GitHub. But yeah, so that's how I did that. Any other questions? Yeah.
That file, is that just a file in your own directory?
Yeah, I decided to put it in. I decided to organize it a little bit better in like LLDB script. So LLDB Python script. Yeah, it could be anywhere. It could be anywhere in your file system, and it could be called anything. Anything else? Any other questions? Yes.
Have you ever used Facebook's chisel commands? Like, just looked it up and it looks like they also extended LLDB in every video.
Have I ever used Facebook chisel? Never heard of it. Yes. That brings me to the slide. Thank you very much. So these are, so here is, here's the Git repo that has the scripts. Here is a blog post from earlier this year that has most of the stuff. This is these slides right now. And Chisel. This is really cool. Chisel is really cool. I don't have time to talk about it, but definitely talk about it. Definitely look at Chisel. This slide is there. There's a lot of resources in here. The thing that I really want to focus on is all these dub sessions that talk about this stuff. And everything that I used for this talk is from 2012 and 2013. Right? So it's been around for a long time. Thank you very much.